Okay, here we are, March 2020. Another lesson. We're doing what? This is 3.2? Yep. 3.2, solving quadratic equations by factoring. So, general form of a quadratic equation is going to be this, which is just your general trinomial that you guys learned in grade 10. A, B, and C are just numbers, right? So they're integers. Yesterday we saw that we could deal with them if they were not integers, right? We solved the questions that had decimals and fractions. Basically our solution was turn them into integers. So this is a big long spiel. We don't need to look at all of this, but we know that we can solve quadratic equations by factoring. Okay, so when we're factoring a quadratic equation, we're setting them equal to 0. Okay, the reason we're setting them equal to 0 is because eventually we're going to be graphing them. So eventually we're going to be saying, oh, y equals this thing, and we're solving for the x intercepts. So y equals 0, and we get this equation that we're going to solve, right? Okay, so this is just a spiel, just saying that we're basically going to solve by factoring. So at some point, like say you're trying to solve this one. So you're trying to solve that one. You'll factor it first. So it factors out like this. Then you get to this step. So you've successfully factored it using whatever methods we learned, and it's equal to 0, and it's like, okay, well now how do I get my x-intercepts? Well, there's this thing called the zero product property. So that's this one right here. And we talked about it yesterday, right? I kind of previewed it yesterday, the zero product property. Oh, right, I keep forgetting that when I scroll, the writing on the whiteboard doesn't scroll with it. So, yeah, when you're looking at this, if any one binomial equals 0, would you guys agree that the whole statement is going to equal 0? Like, if this were to equal 0, so if I replace that with a 0, is that whole statement equal to 0? Yeah, that's what the zero product property says. It's like, look, you got these binomials equal to 0. If even one of them is 0, the whole statement's 0. Can you just hold off, please? I know you. Can you just hold off? I'm trying to do this. So that's what the zero product property says: is you take each binomial and you set it equal to 0, and then you solve, and each one will give you an x-intercept. So that's all we're doing today. We've learned how to factor. And we're just going to factor. When we get to this step, we're going to set each binomial equal to 0, and we'll now have our x-intercepts. And we're one step closer to graphing these things eventually. Because one of the first things we're going to want to know is where are the x-intercepts, if they exist. All right, so let's do a couple questions. Right, before we do that, we've got the strategy. So using the fact that a product is 0, if any of its factors is 0, we follow these steps. So basically, if the equation's messed up, like it's not always equal to 0, sometimes one of the factors is on the other side, or one of the numbers is on the other side, bring everything to the left and simplify it, leaving 0 on the right side. You know, factorize, that's a fun word. Factorize the equation, right? So that's all the strategies we learned in the past few days. Set each factor equal to 0, solve the resulting linear equations, and then you can always check the answers by substituting back in the original. We don't always do that, but you can definitely do that. Do you guys know who this is? No. Barney Stinson? How I Met Your Mother? No? Huh? Neil Patrick Harris, yes, that's right, yeah. Hilarious guy. Okay, here we are. So these ones are not, well, part A is not factored, okay, but it is already set equal to 0 for us. So what we'll do is we'll factor it. It's A equals 1, so it's going to be something like this, equals 0. So two numbers that multiply to -8 but add up to 2, well, that would have to be maybe -4 and +2. Right, now solve your x-intercept. So take each factor, so each binomial, set it equal to 0, and solve for x. So that is the zero product property, ZPP is what I call it. Sometimes in grade 12 pre-calc it comes up as a theory question. So just keep that in the back of your brain tank. So right here, solve for x, you get x equal 4. Solve for x, you get x equal -2. You're done. We can pick one of these answers and check it. So just to demonstrate that that's something that works, let's check -2. So you go back to the original equation. You can plug in -2 and see if it equals 0. So let's see, you get 4, you get 4, and then you got to subtract 8. So 4 plus 4 minus 8 is 0. Yep. So 0 equals 0. Done. You don't have to do this, right? It's just an option. If you're not sure about your answer, I suppose, you can do it. So there's that one. Give you just a quick moment. Try this before. Oh, it tastes terrible. Okay. What if you have it equal to that? Is this equal to 0? No. So the first step in our strategy said, well, you gotta set it equal to 0 if it's not already equal to 0. So this one kind of sucks because we can't just bring the 3 over and set it equal to 0 because we need to bring the 3 back into the trinomial. So in this one, you actually have to FOIL it out. FOIL, then set equal to 0. Well, if you ever see one like that, like it looks like it's red, it looks like it's been factored for us. Right, but because this is not equal to 0, we gotta FOIL this out and then bring the 3 over. Okay, so we'll take the 2x, we'll multiply it into that bracket, and we're gonna get 2x squared plus 2x. And then we're gonna take the -3, we're gonna put it in there, and we're gonna get -3x subtract 3. And then I'm going to subtract 3 from both sides. So I'm going to take this one, I'm going to write subtract 3 equals. Now if I subtract 3 from the right hand side, what is it equal to? 0. Very good. Lots of people will just kind of drop the 0, it just magically disappears. But no, you got to set it equal to whatever it's equal to. Now we can group or like terms and then factor it. And then go through this process. So this one looks like it's going to end up being a decomposition. Because we got a 2x squared, then I get a -x. Subtract 6, that's equal to 0. Is there a greatest common factor you can pull out? Almost. Like that and that divisible by 2, but not that one. So we're out of luck. We just got to do decomposition. So two numbers that multiply to a times c, so 2 times -6, that's -12. Have to add up to the b term, which by the way is what? -x. What's the coefficient? -1, very good. Yeah, so just watch out. So what are my two numbers? Remember, when this is 1, the two factors are 1 apart. So yeah, 3 and 4. And then to make the signs work, I gotta make it -4. Do you guys agree? Perfect. So now you can decompose that middle term. So I'm gonna write the 4 first. I'm gonna go -4x plus 3x minus 6. I double check. Is that equal to -x? It is. So now I'm going to jump straight to the answer. I like that shortcut method that we were doing the other day. Alright, so I know that I'm going to look at the first two factors. I think I got a different color. One moment.
What's the shortcut method? I forgot.
You missed it yesterday, you were away. Yeah, we can go over it later. So we're going to look at the first two factors. What can I pull out? 2x. So you write the greatest common factors in this bracket, and then you write the binomial you get in that one. So when you pull out a 2x, you're going to get x subtract 2. And then you look at the last two factors here, the 3x minus 6, and you're going to put the greatest common factor you get in here. So you can pull out a positive 3. Very good. You guys have been practicing. Okay, now when I pull out the positive 3, I want to make sure that I get x minus 2. So 3x divided by 3 is x, -6 divided by 3 is -2. It worked. So now you have it all factored out, you have it equal to 0, you're ready to solve for those x intercepts. Okay, so you can write x intercepts. So I'm going to take this bracket. The zero product property says you can take one of the binomials, set it equal to 0, take the other binomial, set it equal to 0. And then solve those two equations. So this one's going to give you -3 over 2. This one's going to give you 2. There. So if you were sketching this, you now know your two x intercepts for this quadratic. Okay. Good. This projector is very bright. Any questions? It's basically the lesson. Like, if I was to say, like, we're just going to do the lesson in 10 minutes or less, that would be the lesson. So we'll do a couple more examples. I mean, obviously we can look at more things, like what else can happen. Give you like a wording problem, maybe. So here's another one. Oh, of course. I need like a little grade 9 kid, like, who like comes behind me and like erases the board. Are you guys grade 11? Yeah. We had some grade 8s from River Heights the other day who came in and did some STEM activities with my robotics club, and they were huge. Like, I don't know if they're eating steroids or something. Like, they were as big as you guys. They're grade 8. Yeah, when they get to grade 9 and you guys are grade 12, they're gonna beat you guys up, push you out of the way in the hallway. Okay. Colby, are you worried? No, Colby's not worried. They had nothing on you, Colby. Yeah, no. You guys will have to pay Colby like protection. Yeah. Is that what that earthquake is? All right. This one. Oh boy, oh boy. So kind of similar to B, except this one will be less annoying actually. Because all we got to do is bring that 12x over to the other side. Okay, so remember that first step is set it equal to 0. So I'm going to subtract 12x from both sides. I'm going to get 2x squared minus 12x plus 18. And I just inserted it into the middle here so that I have my trinomial the way I'm used to it, right? Now, is there a greatest common factor or anything like that? Very good. You guys caught that I can divide each term by 2. So if I pull out the 2, then I'm going to get x squared minus 6x plus 9. Now that's really convenient because now it used to be decomp. Now it's just a regular factoring question. So I'm just going to leave the 2 over there. I'm going to just write my little brackets for my binomials. And I got to find 2 numbers that multiply to 9 but add to -6. Very good. Huh. So when the 2 binomials are the same, what does that mean about this trinomial? It's a special one. Yes, so if you get 2 binomials that are the same, that actually meant that that was a perfect square trinomial. So do you see what I mean? Like, it's not the end of the world if you didn't recognize it. And you can still factor it. Granted, if it was decomposition, so this is a perfect square trinomial, it would have taken us a bit longer. But yeah, maybe after I'll show you guys. I don't want to make the video too long, but yeah, we dealt with it. We pulled out the greatest common factor. Now we're here. So the zero product property says that if any of these binomials is 0, this whole statement is 0. Do you agree? Even with this 2 out here? Yeah, very good. I like the confidence. You're just like, yeah. It doesn't make a difference if I go 2 times 0, right? If any of these brackets is 0, the whole thing is 0. So, do I need to do the zero product property twice? Because they're the same. No, so just do it one time. So you recognize, like, okay, it's the same binomial, so I'm just going to do it once. So this is a quadratic that only has one x-intercept. And we'll find out that when we start to graph them, that there's basically 3 possibilities. 2 x-intercepts, 1 x-intercept, or none. Right? Because I mentioned that these things look like this. So one that has 2 x-intercepts might look like that, or like this. One that has 1 x-intercept, what would that look like? I guess it would just touch the x-axis in one spot. So like something like this, we could say, oh, there's the x-intercept 3. What if it had none? Ah, yes, like above, yeah, and opening up. Or maybe it's down here, opening down. Yeah, so that would be no x-intercepts. That's all coming. We're not graphing them yet, but I do like to show you so that when you see them, it's like, oh, I've already seen that before. Okay, so next question.
I have a question, Mr. Henry.
Oh, yes.
So when you do the, you only take what's in the brackets equals 0. Like if you have coefficient element, you just pretend that like that's not 0.
Yes, here, let me show. I'm doing it a little different this year because I've noticed that because we have an equation, yeah, it doesn't matter. Like the zero product property says, as long as everything's being multiplied, if one factor is 0, the whole thing's 0. Now you're wondering about this too. Now this is an equation, right? So if I divide this side by 2 and divide this side by 2, I can get rid of that 2. I guess it was x minus 3, wasn't it?
Yeah.
Oh, whatever. What's 0 divided by 2?
0.
So if you want to, you can make that 2 kind of go away. I can only do that though because it's an equation. Yeah, and sometimes when we do these later, they're not equations, and then people get confused and they start pulling out greatest common factors and then dividing them away. But you can only do it because it's an equation equal to 0. Yeah. So, it's a good question. Next one. What do we have here? Oh, example 3. Oh, it's got a square root in it. Ay, ay, ay. Yeah, by the way, if you have a square root, you need to verify the equation. So even if it doesn't say, you have to check. Check for what's called extraneous roots. Which just means when you have a square root, are there certain values for x that you can't plug in? Like, is the square root allowed to have like a negative radicand? It can't. So if I were to plug in like x is -4, that would give me a square root of -1, which I can't compute. So you have to watch out because sometimes you get solutions that are not solutions. So one way of catching them is to, when you get to your answers, is to substitute them back into the original. You can also like look at this, and the condition for that is x plus 3 has to be greater than what? Greater than or equal to? What's the smallest number I can put in here before I'm negative? 0. So x plus 3 has to be greater than or equal to 0. So if you solve this inequality, which you guys did in grade 9, now I know that my solutions for x, they have to be greater than or equal to -3. That's another way to verify your solution, is figure this out and then look at your solutions at the end and be like, okay, do they satisfy that condition? Okay, well, let's see what we do here. This is going to be ugly. You guys ready? It's not that bad. If you have a square root, you generally need to isolate it. So, isolate square root, and then you're going to like square both sides. Now you got to get rid of that square root if you're going to solve this thing. So I'm going to isolate it by getting it all by itself. So I'm actually going to move the -1 over there, and I'm going to write x plus 3 equals x plus 1. And now that I have this all by itself, I'm going to square both sides. So brackets around that side, squared. Brackets around this side, squared. Don't lose the brackets, because what's special about squaring a binomial? What do we have to do? It starts with an F, ends with an oil. Oil. Yeah. So when you square a square root, you just get the radicand. So you get x plus 3 on that side. That's great. Over on this side, you got to FOIL that out. So maybe over here, I'll do that work. I don't know about you guys, but I just remember the first term has to multiply both of the second ones. So I get x squared plus x, and then this needs to multiply those again. So you get plus x plus 1. When you group your like terms, you're going to get x squared plus 2x plus 1. Now this is starting to look a little bit better. Right, like I got a trinomial here, so I'm going to move all the x's over to one side, all the numbers. So I'm going to subtract x from both sides. So that's going to give me x squared plus x. And then I'm going to subtract 3 from both sides, so 1 subtract 3 is -2. What do I have on the left-hand side now?
0.
Ah, very good, 0. Because I subtracted x, so I got 2x minus x is x. I subtracted 3, 1 minus 3 is -2. Now can I factor it? What do you guys think? Is there anything else I can do? No, there's really nothing else, just time to factor. It's a regular factoring question. A is equal to 1. Two numbers that multiply to -2 but add to 1. Probably what? +2, -1. Excellent. So now 0 product property. Take each binomial, set it equal to 0, and solve. So you get x equal 1 from the right hand side, and over here you get x equal -2. Now, because there is a square root, I would need to check my answers. Am I satisfying my condition over there?
Yes.
Yeah. You can still get extraneous roots. It's not a bad idea to check. So if I plug in -2, let's do it in my head. I get the square root of 1, subtract 1. So let's see what happens. Let me go write it down. So I plug it in, I get the square root of -2 plus 3, so 1. Subtract 1 has to equal -2. So that's 0. Does 0 equal -2? Yeah, it's not a trick question, it doesn't. So what does that mean? It means that this is an extraneous root. So all you gotta do is just put a cross through it like that. And on the grade 12 pre-calc exam, that's understood to mean that you're rejecting that solution. You don't need to necessarily give reasons why unless it's asking. Our reason was we substituted it in and it didn't work. Let's try x equal 1. So you're gonna get, if you try x equal 1, you're gonna get, let's see, square root of 4, subtract 1 equals 1. So this is 2, subtract 1, so 1 equals 1. Do you guys agree?
So for extraneous roots, you have to check for one solution that works.
Yeah.
If you have to check, you have to verify it.
Yeah. Yeah, like one thing you can do is you can do this, and that gives you a condition. Which sometimes, like right off the hop, you'll get a solution that doesn't satisfy that, and you're like, okay, well that doesn't work. But you still need to actually go and verify your solutions if there's a square root. And we won't remind you to do it either. Like this question happened to say verify the solution, but most questions would just be like solve this equation.
Can you go over verifying?
Yeah, so to verify it, I'm simply taking my X intercepts that I found, and I'm substituting them back into the original equation, and making sure that you get left side equals right side. So like for x equal -2, I did -2 plus 3, and that gave me 1. So then I checked, is the square root of 1 minus 1, is that equal to x, which was -2? The answer is no, it wasn't.
How did you do that? X is greater or equal to -2.
Oh, I just set this greater than or equal to 0. Yeah. So you take the radicand, you set it greater than or equal to 0, and you solve it for x. Yeah, and that gives you another little piece of information about whether or not your solutions are actually solutions. Yeah. That's a big question, I guess. There's a lot of work there.
How many marks is that?
I don't know. Probably like 3 or something. Yeah. Maybe 4. I don't know. Don't put me on the spot. How could I ever possibly decide? Probably 3. That'll probably give you like a mark for like getting it to like somewhere around here, and then 1 mark per solution. Like 1 mark for this, and then 1 mark for getting that and rejecting it or something. Something like that. Yeah. Questions? Alright. I believe we have a wordy problem. It's kind of optional, but it's kind of nice to like do a question that's a little bit wordy and has some factoring in it. Sounds like a good way to spend, or what is it, Wednesday afternoon? Guys, I can't wait for the nice weather. It's coming. Another what, 2 months? When do you guys consider the weather to be nice?
Positive.
Like right now? Like we're getting close to like temperatures that are like just below freezing? Spring has sprung? Yesterday it was like -8 with the wind chill.
It was sunrise.
But it's constantly positive.
Constantly positive throughout the day. Because if you actually watch the temperatures, as you get older, you'll watch the temperatures more and more. And like you'll start to realize like it does not go above 0 at night until like the end of June.
Yeah, that's true.
You know, like it'd be nice in the day, it'd be like 20 degrees, 15 degrees, but then it's like at night it'll be like -5. Yeah.
That's nice.
It's okay. It's alright. I remember the first time I realized there's places that have nice weather when we have like terrible weather. I don't think it was until I was like 20. I like went to Florida in like January or February, and I was like, well, it's like 35 degrees down here. I'm like, there's places where it's nice all the time. And the locals are like, yeah, you don't want to be here in July, because in July it's 1,000 degrees and you'll die. I was like, oh my goodness. You guys have such different problems than us. Anyways, yeah, let's do this question. Yeah, that's when my life went downhill when I realized that. No, for real, there's this syndrome called SAD, it's called seasonal affective disorder. Lots of people in Canada have it, and like the weather gets you down. Like you guys ever kind of feel January, February, you're kind of more sad? Yeah. Back in the day, it used to be cabin fever. People would just go crazy. Imagine no internet, no distractions. You're just stuck in a cabin. like there was no TV, he's just staring at the wall, you know? Yeah. Cabin fever. People would like legit go crazy out of boredom. Jory, I like that face you made. You were like, whoa, imagine that. Okay. Doesn't happen in this class. You guys are entertained the whole time, right? Good, okay. Alright, let's do this question so we can be done. What do we got? Rectangular ground, blah, blah, blah. Okay. Did you guys read it yet? No, neither did I. So we got this garden. Perfect. Seeing as we're talking about sunny weather. 5 by 7 meters long, and they're going to be increased by the same dimension x. So it says when that happens, the area of the garden increases by 45 meters squared. And it says determine the dimensions of the larger garden. Great. They did some work. They said let x be the increase in meters. So I'm going to scroll down so we got some room. So what's the new area? Because it said it increased by 45 meters, and I went and I calculated the old area to be 35. So what's the new area?
80.
35 plus 45, is that 80? Okay, so very good. New area is 80 meters squared. So how are we going to do this? Well, what's the formula for area? It's length times width. My length and my width are binomials. Now I'm just going to go ahead. Is it okay if I rewrite them like this, like x plus 7 and x plus 5, just so they're in the order that we're used to? Can I do that? Still the same statement? Yeah, you betcha. So I'm going to try to solve this equation. I know the area is 80, and it comes from going length times width. So that's x plus 7, x plus 5. Now we saw a question like this before, right? It's not equal to 0. We can't find those intercepts. So we need to FOIL this out and bring the 80 over to the other side. So let's do that. So you're going to go x times x. I'll just kind of do that over here. X times x is x squared. You know, x times 5 is 5x. And then 7 times x is 7x. And then 7 times 35. 7 times 5 is 35. There you go. We can group those like terms. We're going to get 12x. So I'm going to get x squared plus 12x plus 35. And then I'm going to subtract 80 from both sides, right? Right, because I need to set it equal to 0. So I'm going to subtract 80 from both sides. And I'm going to go x squared plus 12x. What's 35 minus 80? Very good, negative 45. Now I can FOIL this, or sorry, factor this. So two numbers that multiply to negative 45 but add to 12. Say again, 15? And negative 3, very good. Yeah. So 15 and negative 3, awesome. Now what?
Let's check which one.
Yeah, what's it called? 3 words. So this is that.
Zero product.
Yeah, ZPP, zero product property. So take this one, set it equal to 0. I think my marker is going to be done after this. Okay, so one possibility is that x equals 3. The other possibility, oh, it's really going. The other possibility that x is equal to negative 50. And you got to interpret your answers because it's one of those, you know, real world problems. Can we have like a negative dimension if we go negative 15 plus 5 and get negative 10? No, it just doesn't make sense. So that's an extraneous solution. We can check x equal 3. Does it make sense? If x were 3, what would the dimensions be? 10 and 3 plus 5, 8 meters? Does that have an area of 80?
Yes.
Excellent. So, we found our increase. We're going to increase both sides by 3 meters. The new dimensions will be 10 by 8. And you're done. Thanks for joining us. We'll see you next time.
Bye-bye.